Hello everyone, welcome to today's webinar. We're looking at Python self-marking teaching and learning resources today. With me, Sarah Zaman as your host, and we've got Pete Dring as your presenter, whom I'll shortly introduce. I'm the Community Outreach Manager for the North East for Yorkshire and Cumbria. I oversee the communities in that area and all the community leaders. This webinar is part of the CAS Virtual Showcase, which is a 2-week window of webinars designed to support the CAS community. During the session, please use the question window on the right-hand side of your screen to ask questions. If you make sure that if you want to say anything else, if you use the chat box at the bottom, but any questions for Pete, if you put into the question box, and I'll either interrupt him or we'll keep them for the end. All attendees are in listen-only mode. Top of the window has an orange rectangle which can be expanded or collapsed. If you're using social media today, which would be great, hashtag for the event is #CASVirtual20, but I think you saw that as you came in. And I'll hand over to Pete now. Thank you.
Thank you so much, Sarah, and thank you for getting everything organised. Good morning, everybody. Welcome, and thank you for giving up time to meet together. It's an exceptionally busy time for teachers, so I'm full of admiration for anyone who can prioritise and schedule in some CPD and a chance to network with other teachers. I'll get started. A couple of numbers to start off with. 13. I've been teaching for 13 years. I don't know if that's an unlucky number. Some adventures along the way. I started at a school, well, I've only taught in York schools, started at a school mostly working with SEN students, and absolutely loved it. I remember teaching some students to drive in the school car park without asking for permission from the other teachers in the car park, which didn't go down well with the staff, but did go down well with the students. So I've always kind of approached computing from the lowest ability to try and build it up, because I think that's what I just find the most rewarding. The 3 is the number of schools that I've worked in over the last couple of years, so I haven't moved around all that much. I'm at a secondary school, Fulford, in York at the moment, and had a brief foray into the world of primary school whilst working also at my previous school, and full of admiration for primary colleagues. I don't know how they managed to be master of all trades. I couldn't hack it, so I couldn't continue, but loved it. The 2, I've got 2 kids, a 4 and a 6-year-old, so well done to any parents who are juggling childcare commitments in lockdown at the moment. And the 1, I tried really hard not to be negative, but the one thing that I wish that we could banish from the teaching profession are pointless admin tasks that are just repetitive, data entry where you've done something and you've just got to do it all over again. Why am I sharing this? I guess because the background and the history towards self-marking teaching and learning resources is because I'd rather spend maybe 50 hours making a resource that probably saves me those 50 hours in the future if it means I don't have to go through mindless marking tasks. Feedback, I think, is wonderful. Students really appreciate that. It's really worthwhile, but marking the process of getting to that feedback, I'm afraid I'm just not very good at. But that's not to say it's not worthwhile. So hopefully, the end of this session, we've got 45 minutes together. We are going to look at some resources. They're not the best resources out there. They're not the only resources out there, but I'd like to take some time to share some that have been put together. We're going to look about at the pedagogy. I think it's really important to think about how we can use them in the classroom. Again, I don't have all of the answers, but I hope there'll be some suggestions to try things, both remote learning and when we're able to get into the classroom a little bit more. I'm not really going to focus on subject knowledge, so if you're after some Python CPD, then do check out the NCCE courses or the other stuff in the virtual showcase. So let's start with Createwithcodeuk. I guess lots of people will be familiar with Trinket or Replit, which are both fabulous alternatives to this. I think it was about 5, maybe 6 years ago when I was teaching at Manor, my previous school, doing a lot of live coding with a fab Year 10 group. And we found that they asked loads of questions. They knew how to distract me with a curveball question about codes. And we do some live coding. And then I wanted a really quick and simple way of taking what's on the screen and sharing it with the students in a way that they could just scan it. It was an iPad school, or quickly type out a URL. So avoiding any URLs that have ambiguous characters like a 1 or an I or an O or a 0. So they helped design Createwithcodeuk. It's free to use. And the idea is that you don't need to have any accounts at all to be able to use it or save any of the code that you're doing. So it's designed to work on any device, and you kind of do some live coding in your lesson, and then you run it with Control and Enter, and then it just displays the code up on screen. It's not as feature rich as Replit, but it's a little bit faster. Replit runs on the server, so it has more modules that it supports, and Replit is great for collaborative coding. Createwithcodeuk doesn't do any of that, but it is fast, as in it all runs on the device itself in the browser. A big advantage as well, it was designed for kind of live coding so that you can step through the lines of code one at a time, see all the local variables, see all the global variables. I wanted something we could use in the classroom and something we could use for homework tasks without relying on students having a particular type of device at home or having software that they had to download. So if we say type in Mr. Dring, you can see there's a string variable stored as name, and you can step through Control and full stop each line of code as it runs. So that's where it started from. But then came the problem of, okay, I set these tasks for students to experiment with for homeworks. How do I get that code back from them? So it's possible to save, Control S. You just have to prove that you're not a robot. I've never really understood these things properly. You can make a free account, but I wanted to use it in kind of code clubs or primary school coding sessions where you don't need to faff around with any user details or anything. So you save it, you get a link that hopefully doesn't have any ambiguous characters in, that you can just put up on the screen or share a QR code or something like that, and the students can just get straight to the code. So you can get them to email or submit on Google Classrooms or whatever it is that you use. But I wanted some way of tracking what students do, and importantly, some kind of differentiation so that some students can just tweak the code, some can go in much more depth to try and expand their Python knowledge. So Google came to the rescue, really. They put out a bid for some funding for Google for Education grants. I put in a bid to create and share some self-marking resources, and I got the money, which meant that I had to actually create the resources, and it took ages. Sorry, not allowed to swear while it's being recorded. So the idea is that it still uses createwithcodeuk, but there are now some activities so you can turn your code into self-marking resources. So for some teachers, you might want to know how to create your own. For others, I'll show you and give you the links for ones that have already been made. So let's go and have a look. There's 12 that I've made so far. I've committed to making 20, but you can make your own ones as well. So I'll talk you through this one. It's about Python variables. It's kind of split up into 5 sections. A one-page introduction that just says what we're going to cover. Say, for example, variables to use and store data. Then it's got a page for the theory, which, to be honest, most students just skip. It's there for you to refer back to, but most of my students just want to jump straight into the activities. So you can go back a page to the theory, and it kind of talks through the concepts, variables, what they are, everything like that, with some examples that you can try out. But the important bit is when students start. So the model that we're going with is a try it, debug it, and extend it. The idea is a try it activity is something that students can do with minimal instruction. Hopefully anyone can do it, so the low ability students can engage with it. You don't have to change anything in the code to find some examples that you can copy and paste in your own projects. So I'm just going to open into a new window here.
Pete, can I just ask you something? We've just had a question saying, how did you get the variables up?
Oh yeah, good question. So Control and Enter is run the whole thing, and Control and full stop is run one line at a code to see that. Sorry, one line at a time to see the variables. Control full stop.
Control full stop. Thank you.
Thanks, Sarah. So each of the activities are split up into 3 interactive parts. So try it are ones that you can just run through. What's your name? So Mr. Dring, what's your favorite food? Oh, too many to choose from. Today's a barbecue day. Looking forward to enjoying that. What's your favorite word? My youngest son loves dinosaurs at the moment. So let's go for that. And it's going to say that favorite word 10 times. So I quite like when live coding to give some students some instructions in comments down at the bottom, sub-goal labeling, I think the NCC and the research calls it. And then these challenges are also the things that are self-marked. So you click on the little test thing at the top. And although the code is working in the try it ones, it gives us some challenges to try and work through. So let's change line 3 so we have an exclamation mark after your name. And I've got that one done. I did it just before the session. I think originally it was like this. And then you can see the tests on here as we go through. Come on, let's run the thing again. What's your favorite food? Fancy pizza now. That's my favorite word today. So now I haven't got the exclamation mark afterwards. And as soon as you type them out, you get the instant feedback on here. But also this little tracker thing that appears on each of the pages will tell you how many of the challenges you've got. Now, a bit of a heads up, if you're doing this as a teacher, often students will write the code and they'll get the marks for it, but you actually also just get some credit for viewing the code. That's what the little eyeball means. So I haven't viewed this debug it one yet. And the triangle means you also have to run it. Even if your code is going to work, you have to press Control and Enter to run it to get it there. So the try it ones are some things that you can work through by tweaking, trying to encourage curiosity and creativity rather than just copying what the teacher goes through. And I think that was my biggest takeaway from the first couple of years of teaching programming. I did an engineering degree. I didn't have that much taught instruction with programming, but the stuff I did have was mind-numbingly dull, even though the lecturers were amazing. And I am geeky enough to really enjoy the programming. I hated the programming lessons because it was just watching somebody else code. So I much prefer it if you've got the creative freedom to experiment, but obviously with experimentation becomes panic for lower ability learners because they just don't know the direction. So we're trying to tread a balance between giving students enough direction, but also giving them the freedom to learn. So the debug it ones are recognizing that students just get terrified when they make mistakes. I don't know who comes up with the language of error messages, and it is, you know, accurate, but it's not very helpful. So I wanted a way to get students to build up their confidence, to understand it and build up experience debugging it. So I always say the best thing about an error message is you get the line number, and the line number isn't necessarily where the error is, but it's always on that line or just above it. So let's have a look at line 7. What did it say? Bad token on line 7. So common mistakes. We've missed a quotation mark, and then the tests run. Here we go, bad input on line 10. Music sucks. So music is what we're asking them, the music that they listen to. We've stored that into a variable. We want to display what they've said that they like listening to, and I'm bound to not know what it is because I'm completely out of touch with youth culture nowadays. And then we'll say that type of music sucks. What time is it? Morning. Do you have any pets? Nope. I learned today that Sarah has a tortoise. Sarah, what's your tortoise's name? What type of music?
It's Bobby. Bobby.
Bobby, nice, thank you. What type of music do you listen to? Quiet music, there we go. Quiet sucks. So haven't passed any of these tests yet. Let's have a look and see why. Line 4 should say, really, it's 1 p.m. already. So let's see, what time is it? 1 p.m. Really, time already. So this is another common mistake. Now this one is harder to fix. It's not a syntax error. Syntax errors are irritating because you get the red messages, but easiest to fix because they tell you where the error messages are. Runtime errors are the next easiest ones to fix because they'll crash and it'll tell you where they go wrong. But these ones are the hardest. These are the logic errors. So we've said literally display the word TIME instead of the contents of that variable. So let's try again. 1 p.m. Fab, do you have any pets? Nope. What type of music do you listen to? There we go. Really, it's 1 p.m. already. Well, I thought it said that. Well, that's embarrassing, isn't it? This self-marking test isn't working as we'd expect it to. I'm not going to pause and try and work out what silly thing I've done. You've probably spotted it already. The important thing is that you can see the progress as the students work through. I'll go back and double check after this session. If you've spotted it, do put something in the question box and that'll save me some time. Thank you. The extend it activities are a bit more open-ended. So it's harder to write the tests to guarantee that the students have done these. But without the extended activities, the higher ability students get a bit bored. They can race through the try it ones, they can race through the debugging ones, but they want to apply their creativity. So here we go. What's your name? Write an irritating chatbot that asks lots of silly questions. And if we ask 5 questions, it should hopefully give us the marks. So let's just cheat and copy and paste this 5 times. And I'm hoping if it does, then we'll pass some of these tests. But I haven't created 5 variables because I've copied and pasted and cheated, and we've used the same one each time. So you get the idea. That's what it would look like for students. What it would look like for teachers was a bit of a dilemma for me, because the good paid resources out there will let you make groups and track progress automatically, and there are some free resources out there, I think like Grok Learning, and even Replit lets you create tests and see the scores automatically. I wanted something that would work with minimal setup. So if you go and run a taster session for New Year 6s, or if you do an after school club, you don't have to faff around making accounts. But I also wanted to be able to see how much students had done for homework. So the kind of compromise with that was with these trackers where students can see how far they've got through, was then to allow them to put their names in. So let's say Bobby was it Bobby the tortoise?
Yes, it was. Yeah.
Thank you. And you press the little tick, and it should hopefully generate a PDF certificate with your name and the things that you've got right. So then, however you collect your work from your students, if it's email or I don't know, Google Classroom or Teams or Show My Homework, whatever it is, you can get those PDFs. The students can print them or screenshot them, put them into OneNote. The administration of it is up to you. The important thing for the students is that without us spending ages trawling through their codes and doing the monotonous marking bit, they get the instant feedback and we can see the demonstration of their progress over time. So that was the first stage, and I've still got a couple more challenges that I want to work through. I said I want to make 20. If you want to know how it works and if you want to know how to create your own, then I'll share a link after this, but it's a bit of a clunky syntax at the moment, but it is possible to make your own self-marking tests. So I'll share a link for that just afterwards. Okay, so that's the resources on blog.with.code.uk. Next came a discussion with some teachers, particularly Dan Tate from All Saints, who I work really closely with and who I think is absolutely amazing, gets loads better results than I do at my school. It's just full of creativity. And we've had as a bit of a pipe dream for the last couple of years, a competition between schools where students can have something that they can work on at home that just ticks over their programming ability or potentially some theory in there too, where they can compete against other people in their classes, but also compete against other schools, make a bit of a buzz about the subject, and encourage them into problem solving and software development in the future. So lockdown has finally given us the prod to get that moving. So live.with.code.uk takes the challenges, the programming challenges, and then recording about a 10 to 15 minute video each week that is just live coding. So similar to what I do in a lesson, explaining how a program comes together, showing all of the mistakes, showing all of the thought processes behind how a program comes together, rather than just showing the end product, because students switch off if they just see the final thing. That's probably what they want to see, but what they need to see is how the program works rather than just what is the program. So live.with.code.uk, I'll see if I can find it and show you. Any school can join. Again, you don't have to sign up or do anything. Students can vote for what they want to come up with. I haven't recorded today's episode, but we're going to do some robotics with a Raspberry Pi. If I can work out how to do that in time, oh my goodness. So the idea is each week there's a video. I won't play it on YouTube, but you can see them all on the web page. It's kind of 10 minutes of live coding, and then after students have watched the video, then they can see the code for that activity, and it just links to Createwithcodeuk, so they can run it and tweak it and work through the challenges underneath. So last week's was a Caesar cipher, so it loads some code from a file, which I think was secret.txt, and you've got to work out what the Caesar shift is, which I think was 8 last week. So we were looking at exception handling last week and validation to try and make sure that our code is a bit more reliable. So they've got access to the code, but we also wanted to try and make the process of engaging with codes a bit more interactive, so that it doesn't just become watch somebody else code, tweak the code, and it just becomes a bit monotonous. Also a bit more accessible for lower ability students, and a bit more of a challenge for high ability students, and stuff that they can do on their own. So those were the things going around the back of mine and Dan's minds. So the first was to turn any code on Createwithcodeuk into a typing race. So anything that you have on Createwithcodeuk, if you just change create into type, or if you share it, see if I can remember the keyboard shortcut. Oh, let's do it this way. Yeah, when we share it, it should give you a little dialog box to make a type racer game. Yeah, here we go. And the idea is, it just says, even if you have absolutely no idea what this code does, so you're really struggling with programming, there is something that you can take away from this home learning activity, as in we want to encourage you to boost your accuracy and your speed with typing. Because I do find in lessons that if students are amazing at problem solving and maths and programming, if they struggle with the typing, they just get frustrated. So it's a worthwhile activity. Again, loads of alternatives out there. It's not the best resource, it's not the only resource, but it can save you some time. You have your code, and then quickly and freely just turn it into an interactive typing race. So that's one of the weekly activities. It also links to one of the things I've shown you already, the try it, debug it, and extend it. But the new thing was Kpride. So this came about through Sue Sentence's amazing work on PRIMM. So her methodology was predict, run, investigate, modify, and make, which I think is a really helpful pedagogical approach, as in how to teach stuff. And tried it, loved it, but then when I was running some NCCE training for Python and the first time round, I just felt part of the missing puzzle was debugging, so some more focus on common mistakes, building resilience and debugging, which to Sue's credit is there in the investigation stage, but it sometimes gets forgotten when we implement her recommendations. And actually, crucially for exam practice, the keywords, so getting students to be able to articulate what their program is, and most importantly, how to ask for help. So if a student wants some help but doesn't know how to ask for help, they're not going to be able to Google it, so they can't be independent, and they can't put their hand up if they're in a lesson and say, "Sir, can you help me with validation?" because they don't know what validation is. So the idea with Kpride is, again, it will take any code. So you start with stuff that you've saved for free on crate.withcodeuk. And then instead of doing a type race share thing, you just go Kpride and you've got your link here. And it will try and automatically identify about 30 different Python concepts and turn it into a self-marking quiz. So these are the keywords that might potentially come up in an exam. Say, I do Edexcel, but other exam boards too might have some code in pseudocode or Python. New specs tend to be just Python. And it says, what line number do you see variable assignment on? And even if students are amazing at writing code, they might not know that that's what they're doing. So let's have a look. An arithmetic operator. The idea is we have to try and find something like here where there's an arithmetic operator. And if they don't know it, they can have a couple of attempts and it will highlight all of them. It's not perfect. Sometimes, because it's automatic, it doesn't get all of them, but it hopefully gives you an idea, and it's instant feedback. You don't have to wait for them to screenshot it, email you, you reply a week later, and then they found out what it is. Hopefully, they've got a little overview of what all of these key concepts are. They can find out variable assignment. So here we've got a Boolean value, a true or false, that we're assigning to a variable called valid. And we've also used it in lots of other places. Anywhere where we're setting a variable is assignment, and it just ticks them off. So that's the first part of Kpride, keywords. The next part is predict. This part most of my students skip over. They find it infuriating and irritating. I quite like it, but I don't know, I'm open to feedback. The bit that they find irritating is that you can't just skip past it. You've got to say what you think will happen. So for example, display Caesar cipher, or say what's stored in each variable. And then when you press run, it will say what your predictions are, it'll run the code, and you've got to tick off, does it do that, does it not do that? The idea is that hopefully if you're doing this in a lesson, you can screenshot it, you can put it into a worksheet, you can submit it via OneNote or Google Classroom or however you're doing this, just as evidence of the fact that they've engaged with the code rather than skim read it and not really understood it. So the point is code comprehension. Can they predict what's going to happen and then running it to actually test their predictions? Investigate is kind of using the comments at the bottom of the code. So it's an opportunity to follow these, to use a bit of creativity. So the first challenge was make your own secret message. So we'll make a new file called, I don't know, a secret recipe. I'd love to know the KFC secret blend recipe. I am rather missing some fast food. Other fast food chains are available. So you can put your own Caesar cipher encoded thing in here, and they can work through the challenges at their own pace. That's investigate. And then debug is mean, but I think really valuable. So one of my favorite activities is Alan O'Donoghue's sabotage approach. So encouraging deliberate error messages. So we spend some time writing code. So with year 8, we do a chatbot activity. Some students love it, do it perfectly. Some students really struggle. But at the end, we don't submit just the working code. We get students to submit the deliberately sabotage code, which is a great leveler, because the ones who've struggled, the other people don't know if they've actually done really well and been really mean in sabotaging their code, or if they've just made all the mistakes. It doesn't really matter. The point is, I think you actually learn loads by trying to fix error messages. Sorry, waffle and sidetrack. The debug activities deliberately, automatically injects some common error messages, some common errors into some Python code. So you can throw any code at this Kpride activity. And I spoke to some teachers on Twitter, and they very kindly listed the things that students get wrong or that we make mistakes with, like missing brackets or unbalanced quotation marks or capitalization that isn't quite right. And there's an algorithm behind this that will just try and automatically do that. So let's see if we can de-sabotage it. Bad input on line 7. So the advice to students is don't panic, ignore the bits we don't understand, try and guess what we think that we can get from here. So syntax error, there's a problem with the rules of the language. On or before line 7, let's have a look. So line 7, yeah, we've used a capital W instead. Line 31, and when you go to debug, it should try and put 5 errors in there, but you can sabotage it as much as you like. You can press that button and eventually your code gets unrecognizable. Line 31, let's have a look. Yeah, here we go. So mismatched brackets. So what's happening here? CHR takes some text and, no, sorry, a number, and it converts that number into a letter. So CHR is a built-in function. A function needs to have round brackets because you pass some data into it. Hopefully that'll do it. Come on, here we go. Oh, it's working. Secret.txt. So we've got rid of all of the syntax errors, but it's quite possible that we'll have some logic errors and some runtime errors. Let's see. And it looks like it's kind of worked. So sometimes it kind of puts errors into comments, which is a bit pointless, but it gives you an idea, an instant interactive activity that you can encourage students to do on their own to build up their resilience. That's the idea. And then finally, extend. This is the one for the higher ability students. So if I'm honest, most of my students for remote learning haven't really bothered to do, well, that's a bit unfair on my students. They haven't evidenced the fact that they've done this. And it's probably not right to expect them to do it all of the time because it is much more time consuming. But it's moving away from the very tightly controlled directed activity that's fine for lower ability students and just beginning, to the more kind of top of Bloom's taxonomy, synthesis, creation kind of activity. So the idea here is it links back to what's been discovered at the start. So we throw some Python code at Kpride, it will analyze it and work out which keywords we've used. Extend then gets rid of the code but keeps all of the things that it used. So we've now got to try and write our own program that uses an arithmetic operator. So let's have a look. 1 plus 1 should hopefully now use an arithmetic operator. And then we've got to use assignment. So we need to save that value into a variable. And we'll probably tick a couple here if there's one for variables. Oh, we've also used integers. So it doesn't really tell them what to create. I couldn't think of a way to implement that to be clever enough to give them project ideas, but it's kind of checking to see if they can use these skills, use as many of them as they can to create their own programs. So that's Kpride. Again, it's not the only way of teaching programming. It's not the only way of approaching pedagogy. And it's certainly not saying that all of the previous approaches or other approaches are invalid. It's just another tool in our toolbox, I guess, as teachers, so that we can vary things. The idea was to go from writing some code that we can do live coding in a lesson to instantly and freely have something that we can quickly share with students to make the process a bit more interactive. Because I don't like the whole programming is boring thing. Programming is probably the most creative thing that we can do. Watching other people program, like what you're doing now, apologies, is mind-numbingly boring. But having the opportunity to create, do something that nobody's ever made before, and to make something to solve problems, that's an inherently creative process. And if we can get students to enjoy that, it's not an instant thing. We have to kind of guide them through the process. So the idea is you start with just simple recognition, building up the confidence, boosting the code comprehension, getting them to engage with it, getting them to have the confidence to tweak it for themselves, boosting the resilience by finding out what happens when things go wrong, and gradually boosting the confidence to fix it for themselves, to the point where we can say, right, go and make your own programs, don't really mind what it does, just use these skills. So that's...
Can I just ask something there, Pete, just because we've got 50 billion questions, but this one's relevant to just now. I can't even keep track of all the questions. So just a quick question for Kpride. How do you utilize this? I'll read it all. How do you utilize this in a lesson? Do you give the activity to the whole class and they work their way through the stages, or do you move the whole class through each stage, or something else?
Yeah, good question. And there's no right or wrong answers for this. To be honest, I've used Kpride much more in homework activities than in lessons. I tend to just use the keywords activity as a little bit of a break, kind of a 5-minute, right, we've done some theory all together. Now see what score you can get from this live coding thing. So we'll go through a program together. I'll share the link with them. We use a VLE to share links. We're a bit backwards. We haven't used Teams or Google Classroom yet. And then they just work through the keywords activity at their own pace. But it depends where the students are. I think the worst thing that you could probably do is every single time you create some code is religiously go through, right, 5 minutes keywords, 5 minutes predict, and then to be stuck in a pattern breaks the creativity of it. And although routine is helpful, my students don't really respond that way. So if students are struggling with resilience, then just throw a debug activity at them. If you've got an exam coming up and they need to do some code comprehension and spot things from pseudocode or Python code, then throw loads of keywords activities at them. If you've got some students that are racing through things, then give them some of the extend activities to work through whilst we go around and support the weaker students. So great question, and sorry to fudge it with a politician's answer of not really answering the question, but it's really up to us. We can choose. You said there were lots of other questions. Now's a good time if there's any others that you want to choose.
Yeah, there is. There's absolutely loads. Right, okay. If you were a beginner to Python, could you use this?
Yeah, again, good question. And I guess it depends. Are you a beginner as a teacher? Are you a beginner as a student? If you're a beginner as a teacher, you might not be as comfortable with the live coding aspect, writing it out in front of students, sharing the link, and then instantly getting them to do the activities. Although I would encourage you to do that even if you're terrified by it, because I think students learn so much more from seeing our mistakes than they do by seeing an end product. If you just want some pre-made stuff, let's see if we can find it if we search for Kpride. Yeah, create.withcode.uk/Kpride. There are for each of the 12 try it, debug it and extend it activities, there's a Kpride activity that goes with it too. So say for practicing runtime errors, you can just quickly get that activity. You don't have to write out the code and make it yourself and then give that to students. Could students use it if they've never used Python? I think they probably need a bit of an introduction to it first. I wouldn't launch straight into Kpride if students have never written any Python code before. But that's really where the live.withcode.uk things come in, because although there are these 4 remote learning activities for each week, and again, as a teacher, you can say, only do this one, or choose which one you want to do, or do all of them, or do all of them apart from this rubbish one, like whatever you think. I think the most value for beginners is the video. And if you get irritated by my voice, just mute it, turn subtitles on and press the arrow keys to skip through. But the idea is it shows, I've tried to kind of, let's turn the volume off, put subtitles on, subtitles English. You can see the program come together, and I've tried to highlight all of the key concepts, variable assignment, the theory behind it, building up the program step by step. So yeah, if students are struggling, if they haven't done it before, they probably won't. Well, it depends how motivated they are. The YouTube stats show that most people only watch, say, the first 2 minutes out of 15, which is rather depressing considering how long it takes to make them. But students dip into what's useful for them. So yeah, I don't really want to force students to watch something that's pointless. But the idea is you can see the program come together, and the idea that a program isn't always linear. Sometimes you start with a concept and then you build around it. So sometimes it's helpful just to have that thought process explained.
Thank you.
Does that help, Sarah? Is that...
Yeah, that's really helpful. Thank you for that. And also we've got, will this website work if students are using a tablet?
Yeah, good question. It won't work as well because I think writing code on anything other than with a physical keyboard is rather painful. But yes, it does work. It works on most devices I've tested it on. It's pretty horrendous and horrible on a Kindle, but it does work on Android tablets and iPads. And if it doesn't, then just use the contact page on the web page, and I'll try and fix it. Because that was really the main point of creating it. I don't want students to have to make an account. I don't want students to have expensive kit. Even the touch typing thing, there's like an on-screen keyboard thing that you can use. With Kpride, the keywords thing, if you're using a phone or a tablet, the irritation is that you can't click on the line number. So on my phone and probably other Android phones, you have to type in the line number and then press check. But that's the only issue I'm aware of so far. But if you find others, please do let me know, because I want it to be as accessible as possible. Good
Brilliant.
question.
We've got more. Which year groups do you use it with?
Yeah, good question. Used in anger with year 9 and year 10, so in lessons, Kpride's activities and the try it, debug it and extend it for homeworks, where all of the students are expected to engage with it on some level. But I've also opened it up to year 7 and year 8, just because there are some real keenies in there in remote learning who race through the online activities that we've given them. And it's been quite eye-opening to see. The vast majority don't choose, and I always say with remote learning, I give them kind of a menu of activities. So most of them don't choose the Python weekly learning activities, but quite a few do. I've seen some people give them to primary schools. It suggests that it's quite advanced, but it's certainly possible. You know your students better than me. Try it. If it doesn't work, abandon it, go for someone else's resources. I'm not claiming that these are the best ones out there.
Thanks, Pete. I mean, just to add to that, and not to talk about myself, but I am a primary school teacher, but I did do 2 terms in year 9 with some computer science children. And I actually found these by accident. So I actually didn't even know Pete then. I found these by accident and used these in class, and they were just brilliant. So, you know, I had children in that class, year 9s, who hadn't done any Python before, and I had some children who had. I would definitely think from the year 9s, the ones who'd done a little bit of Python before, you know, they flew with this, but you know, they're absolutely, I have to say, absolutely excellent resources. And I think I agree with Pete as a primary school teacher. You know, there are some year 6s, 7s and 8s who could access these, but I wouldn't, like, you know, Pete says, do it as a whole class thing. I think it's got to be for a challenge, because we don't want to put children off, but they loved it. So that was just my thoughts on that.
Thank you, Sarah.
I'm just seeing what else. It said, somebody's put, what other projects you are yet to address?
So is that for the try it, debug it and extend it ones? To be honest, I can't remember. There's a list of them on blog.withcode.uk, so let's have a look and see. I think file handling I haven't done anything with yet, but I'm conscious that people have voted for that in future live.withcode.uk sessions, so I need to get and create those for next week. Where are we? Where's the next page? And if there's ones that you think would be helpful, then do suggest them, but these are the ones that I'd like to work on. So files, error handling, so validation and exception handling, procedures and functions, passing arguments and parameters, optimization, so trying to make your code run as fast as possible or reduce the number of lines, and then ideas for extension, what students can do if they've managed to work through all of these.
Thank you. That's great. I've got another question because we haven't got loads of time left, but we've got, does the Kpride generate a certificate?
No, it doesn't, but if you're interested in tracking students' progress with the Kpride activities, so remember I said with Dan Tate at All Saints, we wanted to set up this kind of scoreboard for students to work through. So you can just dip into the live.withcode.uk resources and use any of them in any order, but you can also set up a school account, and it's fab to see lots of schools getting involved, and then create groups for your students, and then any of the try it, debug it, extend it activities, that automatically gets tracked and you can see students' scores. And the K part, I haven't managed to make the tracking for any of the other bits yet, but particularly the keywords quiz, that also gives students points. So as students work through, say, the typing activity, you can see their typing speeds. The keywords activity, you can see how many of those they've managed to identify. I can't show you examples, I'm afraid, because it will show students' names, but you can track students' scores, a breakdown of their activities, download it as a CSV file, and you can also see the code that they've done. So once you've set up a free school account and made your group accounts, you can choose to subscribe to the weekly competition things. So with no effort from your part, you can just instantly get all the activities that I push out each Wednesday. They'll appear in your group pages. And then once students are logged in, again, it's free for them to do that. Any code that they write on create.withcode.uk, you'll see that code so that you can give them feedback or track that or work that through, because that was kind of the missing piece of the puzzle. So yeah, good question.
Thank you. We are going to have to come to an end. For people, you've had loads of positive feedback, Pete, in there. You know, everyone's even, you know, not even. I think your presentation has just been amazing and loads to take in. For everyone else, if you've got questions for Pete, I'm pretty sure that he's in the CAS Facebook groups, aren't you? CAS Facebook secondary. If you want to put some questions in there, you know, just say that you've watched this, and then I'm sure he'll answer your questions there about anything that you thought of from this presentation. So hopefully that's all right. I'm going to try and find some way of writing down and sharing the answers to the questions that we've already answered as well for you. So just Pete, well, for everyone, thanks for joining us today. Thanks, Pete, for presenting. It's been amazing. Personal highlights were pretty much everything. I didn't realize that you could have certificates, because obviously I was self-taught for the site, so didn't realize you could get certificates. That's absolutely brilliant. Everyone else, you know, please share what your personal highlights of this are on social media if you can. At the end of the webinar, a short survey will appear on the screen, and we'd be grateful if you could complete the survey. And additionally, in about a week's time, you'll receive an email with a CPD certificate confirming your attendance. A recording of this webinar, because I know people have been asking that, will be available on the CAS website in the near future. We hope to see you at other sessions in the showcase. Please do continue to spread the word about the first ever CAS Virtual Showcase. And like I said, you know, carry on these conversations on the CAS forums, because Pete's on there as well, and the CAS Facebook groups. Thanks for joining. Hope to see you next time. It's been fantastic, like everybody said. Absolutely brilliant. Loads of thank yous, Pete. Can't even tell you.
Well,
Absolutely.
thanks for taking part, everybody, and thanks, Sarah, for making it happen. All the very best. Have a great day.
Okay, thanks very much. Thank you.